My kind of town, Chicago is. My kind of town, Chicago is.
In 1893, the beautiful city of Chicago was home to the Columbian Exposition. The Columbian Exposition was the first major American fair since the Philadelphia Centennial Exposition in 1876, and it marked the beginning of a golden era.
One of the greatest inventions at the fair was the Ferris wheel.
Hi, I'm Sari Michelle.
And I'm Noah Gordon-Durban.
And if you couldn't tell, this is the name of your Ferris wheel.
The first ever Ferris wheel was invented by George Ferris for the Columbian Exposition.
The Ferris wheel is considered an engineering wonder. 2 140-foot steel towers supported the wheel. They were connected by a 45-foot axle, the largest single piece of forged steel ever made up until the time. The wheel section had a diameter of 250 feet and a circumference of 825 feet.
36 wooden cars held up to 60 riders each. The ride cost 50 cents and made a total of $726,805.50 during the World's Fair.
10-inch steam pipes fed two 1,000-horsepower reversible engines, one to be used for driving the wheel and the second being held in readiness as an emergency reverse.
A Westinghouse air brake was used to control the wheel and hold it motionless when desired. The Westinghouse air brake system used air pressure to charge air reservoirs on the Ferris wheel. Full air pressure signaled when to release the brakes. A reduction of air pressure signaled the wheel to apply its brakes using the compressed air in its reservoirs.
A hydraulic cylinder was attached between the base and the wheel support tower on each side, about halfway along the length of the tower. The hydraulic cylinders were used to raise the towers into the upright position when the Ferris wheel was in operation. The cylinders were secured into place with a pivot pin at each end. A separate lateral support arm was attached near the top of each wheel support tower. When the wheel support towers were raised for operation, the lateral support arms were pulled out to the side. 2 pieces of square tubing were hinged to the base frame on each side and swung out to attach to the bases of the lateral supports. This gave the Ferris wheel the required side-to-side stability it needed. But chief architect of the fair, Daniel Burnham, worried about the stability of the wheel, so he advised the construction of a heavy block below the wheel to shift the center of mass closer to the ground.
The steel towers were embedded and bolted into 30 feet of concrete. They were calculated to support 5 times the weight and wind pressure produced by a tornado of 150 miles an hour. Motion was imparted to the mass by means of huge cogs in which a link belt fit. George Ferris ensured there was a powerful brake operated by compressed air if there was a need to stop the Ferris wheel.
Today, Ferris wheels are large, non-building structures that rotate around a central axis.
Seats are attached to the outer rim of the wheel and always hang downwards. This is because as the Ferris wheel spins the seats, they can freely rotate at the support where they are connected to the wheel.
The Ferris wheel spins upwards with the help of gears and motors while gravity pulls the wheel back down again. People feel lighter at the top of the Ferris wheel and heavier at the bottom. While the mass never changes at different points during the revolution, it is where centripetal acceleration comes into play. A typical Ferris wheel rotates at a constant speed, but the velocity is changing every second. A person's apparent body weight varies depending on the place on the ride. A person can feel his or her true weight when the centripetal acceleration is pointing horizontally and has no vector component parallel with gravity.
At these two positions, centripetal acceleration presents a vector, which is parallel with gravity, so these two positions can be added together.
Standing on the earth, people are 1 gram. At the top of the Ferris wheel, the passengers may experience 0.5 grams, thus they feel lighter.
When a person reaches the bottom of the Ferris wheel, rotation and weight combine in greater acceleration, meaning people feel heavier. At the bottom of the circle, centripetal acceleration, which always points towards the center of the circle, is pointing directly up. At the bottom of the Ferris wheel, the passengers experience 1.5 grams and they feel heavier.
Currently, a popular amusement park ride is the double Ferris wheel. The double Ferris wheel works similarly to a single Ferris wheel, only the double Ferris wheel has 3 axes instead of 1. The major axis of a double Ferris wheel is in the center of the ride and is connected to a bar. At both ends of the bar are 2 separate axes on which 2 wheels turn.
In our problem, the central axis makes a full revolution every 30 seconds, while each smaller wheel fully revolves every 20 seconds.
We chose a cosine function so that the y-intercept is above the origin. We know that the sinusoidal axis will be at 10 because that is where the center of the small wheels are. The equation is now negative 10 cosine, and because it takes each person 20 seconds to fully revolve around the wheel, we can divide 2 pi by 20, which simplifies to pi over 10. And we can multiply 2 pi by 20, or pi over 10 times t, or the amount of time that Margaret is on the wheel. Our equation now will look like this, negative 10 cosine pi over 10 times t. Because we know that the Ferris wheel is elevated 2 feet off the ground, we can add 2 to 10, or Margaret's height, and get 12, which will be the vertical shift. And now our equation will look like this. Then if we graph the function, it will look like this.
If we know that Margaret's wheel has a 10-foot radius and the space between Margaret's wheel and the center of the ride is 1 foot, then 10 plus 1 is 11, which means that the sinusoidal axis will be at 11. So our equation will start with negative 11 cosine. And because the bigger wheel makes a full revolution every 30 seconds, 2 pi over 30 is pi over 15. Our equation will now look like this. Because the sinusoidal axis of the entire ride is 23 feet above the ground, the vertical shift is 23. Our equation will look like this. And our graph will look like this.
The smaller wheels and bigger one rotate simultaneously. To find Margaret's position on the ride, we can add the two equations. Since this is the graph of the entire ride, we only need a vertical shift of 23 because that accounts for the entire ride from the central axle. Then, if we graph it, it'll look like this.
The period of a function can be measured from the lowest point to the lowest point. This represents the graph of a full revolution of the wheel. So if we measure from the bottom of the first curve at 0, then the next time that curve reappears is 60 points away. So the period will be 60.
Hey Siri, so if the Columbian Exposition is the World's Fair, then what else was introduced at Expo?
Great question, though. An invention that's vital to our lives today. The light bulb.
Starting in the 1880s, Thomas Edison and Nikola Tesla were involved in a battle known as the War of the Currents.
Edison developed direct current that runs continually in a single direction. During the early years of electricity, direct current, or DC, was standard in the U.S. Yet direct current is not easily converted to higher or lower voltages.
Nikola Tesla believed that alternating current AC was the solution to this problem. Alternating current reverses direction a number of times per second and can be converted into different voltages relatively easy using a transformer.
Edison, not wanting to lose the royalties he was earning from his direct current patents, began a campaign to discredit alternating current. He spread misinformation saying that alternating current was more dangerous, even going so far as to publicly electrocute animals using alternating current to prove his point.
The Chicago World's Fair took place at the height of the current war. General Electric bid to electrify the fair using Edison's direct current for $554,000, but lost to George Westinghouse, who said he could power the fair for only $399,000 using Tesla's alternating current. It would appear that the alternating current had all but obliterated direct current.
Today, our electricity is still predominantly powered by alternating current, but computers, LEDs, solar cells, and electric vehicles all run on DC power.
Thomas Edison was not the first inventor to create incandescent bulbs, but rather the first to create a safe, easily replaceable bulb for home use. However, Edison's bulb was revolutionary in many ways. His bulb was the first to use carbon-coated filaments because carbon was the only material he had access to with a high enough melting point, and he used a vacuum in his bulb to prolong the life of the light by preventing its filaments from oxidizing too quickly.
Edison patented his own light bulb design and AC system and forbade Westinghouse, who bought Tesla's AC current, from employing his incandescent screw-in bulbs for the exposition. Westinghouse was forced to return to the drawing board and redesign a suitable light bulb model for the fair.
Westinghouse produced the bipin-based incandescent bulb. His bipin base had a more exposed socket, allowing for greater air pressure to the neck of the bulb, preventing the neck from reaching immensely high temperatures.
Today, incandescent bulbs use tungsten filaments because they have a higher electrical resistance than carbon filaments. Our modern incandescent bulbs work similarly to Edison and Westinghouse's bulbs.
In an incandescent bulb, light is seen as a series of particles called photons. They are created when an atom suddenly gains and loses energy. When an atom is energized, its electrons shift further away from its core. When the energy stops, the electrons return to its natural orbital, releasing built-up energy as a photon. By repeatedly energizing atoms, it's possible to generate a steady stream of light energy.
So it appears the War of the Currents may not be over yet. But instead of continuing in a heated AC versus DC battle, it looks like the two currents will continue to be vital parts of our daily lives. And none of that would be possible without the genius of both Tesla and Edison. Another kind of light bulb whose precursor was displayed at the fair was the fluorescent light bulb.
Fluorescent light has more complicated light emission mechanism than incandescent light. Ultraviolet rays created within fluorescent lamps are transformed into visible light that we can see. Fluorescent lamps are slender glass tubes coated with fluorescent material on their inner surface.
Fluorescent lamps contain mercury vapor and inert gas. When a current is sent through the bulb, electrons hit the mercury atoms, and energy is transferred to the mercury electrons, pushing them into a higher orbital. When these electrons return to their original place, they release their energy in the form of ultraviolet radiation. The ultraviolet radiation is converted into visible light by the phosphor coating on the inside of the glass bulb.
Fluorescent lamps are not always straight tubes. They come in other forms, such as rings and bulbs. We hope you enjoyed our trip around the physics of the Columbian Exposition.